Have you ever pondered over the question, what if suddenly Earth turned into a black hole? A fascinating thought, isn't it? But to make this a reality, Earth would have to undergo an unthinkable transformation. Our homely planet would need to collapse into an extremely dense state. Imagine all of Earth's mass, every mountain, ocean, and city, compressed into a space so small it's hard to fathom. This would require a level of compression that's beyond anything we've ever seen, transforming Earth's entire mass into a minuscule point. But here's the catch. For Earth to become a black hole, it would need to have a mass equivalent to that of a stellar black hole. That's a mass so colossal, it's theoretically impossible with Earth's current mass. So if somehow the impossible happened and Earth became a black hole, what would be the effects? Let's dive into this hypothetical scenario in the next scene. Contrary to popular belief, the gravitational pull at the moon's orbit would remain unchanged. You're probably wondering why? Well, it's because gravitational force depends on two key elements, mass and distance. If the Earth transformed into a black hole, its mass would remain the same. It would just be more densely packed into a smaller space. Therefore, the gravitational pull at the moon's orbit would be identical to what it is right now. Interestingly, this implies that the moon would continue its merry dance around the Earth, or rather, our newly formed black hole, just as it does today. No sudden hurtling into the abyss or drastic changes in its orbital path. It's a fascinating concept, isn't it? But while the moon might carry on as usual, the Earth would be a black hole, and with that comes a new boundary, a point of no return. So the moon would continue to orbit this black hole as it does the Earth today. But what about the boundary of this black hole? Welcome to the event horizon, the point of no return. In the realm of black holes, the event horizon is the ultimate boundary, a point beyond which nothing, not even light, can escape. Imagine the Earth transformed into a black hole, compressing all its mass into a tiny, dense state. The event horizon formed in this scenario would be remarkably minuscule, a mere few millimeters across. It's hard to fathom, isn't it? This tiny boundary, this event horizon, would mark the end of the known universe for anything that crosses it. Once anything, be it a particle of dust or a beam of light, crosses this boundary, it is forever lost to the black hole. This is the power of the event horizon, the threshold that separates us from the unfathomable mysteries of a black hole. But what happens if you get too close to this black hole? Close to the black hole, things get a bit stretchy. You see, as we approach the transformed Earth, the tidal forces intensify due to the steep gradient and gravitational pull. These forces are so strong that they would lead to spaghettification, a process where objects get stretched and compressed when they come too close. Picture a piece of dough being pulled apart. That's what would happen to any object unfortunate enough to venture too near. But that's not all. The Earth, having transformed into a black hole, would become a void of darkness. It would emit no light or radiation detectable to the naked eye, essentially disappearing from our visual universe. Yet, it might not be completely silent. According to quantum theories, it could emit a theoretical type of radiation known as Hawking radiation. Now that we've explored close to the black hole, how would this transformation impact the rest of the solar system? The sudden transformation of Earth into a black hole could cause quite a stir in our solar system. Imagine our satellites, those silent sentinels circling above us. Their orbits would be significantly impacted, possibly leading to a loss of communication and observation capabilities. Then there's our moon, our constant companion in the night sky. Its orbit would remain unchanged if the mass of the black hole remained the same as Earth's. However, if the mass distribution of the newly formed black hole were not perfectly symmetrical, it could affect the moon's orbit too. And let's not forget about our planetary neighbors. The orbits of other planets, especially those nearest to us like Mars and Venus, could potentially be affected, leading to a reshuffling of the solar system as we know it. As we can see, the transformation of Earth into a black hole would be an event of astronomical proportions, with implications far beyond our planet itself.